Hey there, Year 11s. Apologies for not being able to teach this content in class today. I'm not here today, but I've left you a little video tutorial on how to tackle exercise 13F using logarithms to solve exponential equations. So the learning goals for this lesson is we'll be looking into the workings of logarithms, which we saw in the previous lesson, and how they tie in with exponential functions and exponential equations. The success criteria, so what you'll be able to achieve or demonstrate, is to use logarithms in conjunction with your class pad calculator to solve for exponential functions. So we've seen logarithms in the previous lesson, and it was a bit of a new concept to digest, and we saw that there were 5 different laws to help us out. In this case here, we're going to be using logarithms in conjunction with the ClassPad calculator. So you will need your ClassPad calculator to help you solve for questions that look like this when you have, again, the x as the unknown. What we were so used to prior to this is using the solve function. If we were to use our ClassPad calculator to solve for this, we would just punch in solve, enter 2 to the power of x is equal to 11, and then just state to the calculator that we're solving for x, and then x would be provided by the ClassPad calculator. What we want to do is actually write this into the logarithm format. So here we have, right here is our base, and that is our power right here. So how to tackle this question? We're going to just rewrite this in the logarithm format. So as a recap, remember we always start with log, short hand notation, logarithm. We want our base to be the number that's just below the log. So log of base 2 of 11. As 11 here is the answer we've obtained from 2 to the power of x. This here is equal to x. So log base 2 of 11 is equal to x. Now we can just go ahead and punch this into our ClassPad calculator. So go ahead and grab a ClassPad calculator. I've got mine here, my little emulator. You want to go into main, and in keyboard, in math 1, there is a log button here that you'll press, and it comes up with 2 squares. It wants to know what your base is, which is 2, and what we're trying to find the log of base 2 of, in this case 11. Enter that. Nice and simple. Our x value is equal to approximately, and we'll round that to, we'll go 5 decimal places for this one. So our x is approximately equal to 3.45943. And there is our x. That's our power. That is the only power, or approximate anyways, that can work for 2 as our base. So when you're using your calc, try to get out of the habit of using the solve function and get into the habit of actually using the logarithm tool. Second question here. Same concept. We're going to write this in the logarithm format. So we will start with log what our base is. In this case, it's 3. So there's our base. What we're finding the log of, so 28. And this is going to be equal to whatever the power is. In this case, it's 2x minus 1. And now we are solving for x. Again, we're going to use our ClassPad calculator, but there's just a little bit more that we're going to do algebraically, because in the first example, we only had a pronumeral as our power. There was only just one of them. In this case here, we've got terms that are tagged wrong. We've got a coefficient and we've got a minus 1. So we just have to do a little bit of rearranging in order to get our x by itself. My OCD always wants me to put whatever I'm looking for on the left hand side. So I'm going to write it like this, and then I'm just going to go ahead and do my inverse operation. So I'm going to add 1 to both sides. So this is equal to 2x is equal to log base 3 of 28 plus 1, because we're adding 1 to both sides. And then we're going to divide both sides by 2. So x is going to be equal to log base 3, 28 plus 1 all over 2. Again, class bed calculator, and we're just going to punch this one in. So we'll start with our fraction. We're going to put in our log of base 3, move across 28, move across, and we're going to add 1. Now, we always leave these brackets here. I think they're just stuck in there by default, and that just makes sure that the calculator knows what you're trying to find the log of. Because that plus 1 is not attached to that log, because it's a separate term. We put that on the outside of the bracket. So just be careful that you don't put 28 plus 1 within there, because then we'll find the log base 3 of 29, which is not the case. This has all been divided by 2. Go ahead and execute that. And we'll do this to 3 decimal places. So our corresponding x value is approximately 2.017. That's to 3 decimal places. By default, just do 2 to 3 decimal places unless the question specifies otherwise. Last example here. So the reason why we've been looking, and this is based on the success criteria, the reason why we're using this logarithm skill is because when you're told to sketch a certain equation, an exponential equation, the very first things that you do is you need to find the x and y intercepts. Now we did have a technique in order to find the x-intercept where we just use a solve function. But in this case, we've now got a proper tool. We can actually use our logarithm skills or a logarithm approach to get what this x-intercept is. First of all, there's a few things that we need to highlight. So this particular graph here, right here, this 2 that is hanging out the front is our dilation. So this dilates the 10 to the power of x. Obviously, 10 is our normal base. This minus 4 particularly, this here is a translation. We know that this is being shifted 4 units down. The proper notation for this is a translation 4 units in the negative direction. And it's negative because there is a negative number that is attached to that 4. So negative. Okay. Other things that we can also state is that from the graph we can see that as x approaches negative infinity, and so as we keep going along the x-axis and we keep going this way, so we're going in the negative infinity direction, we can see that this line is going to tend towards where our asymptote is, which is at y is equal to negative 4. And again, it is negative 4 because of this minus 4 here, because of that translation or that push that goes down. So as x approaches negative infinity, y is going to approach negative 4. Remember, this is coming from the positive direction. Because it's above this y equals negative 4 asymptote, it's coming from the positive direction. So just remember that little plus. If it was coming from the other side, from up here, so there was an inverse or inversion of some sort, this will be from the negative direction. But because it's just your standard exponential, it's coming from the positive direction. And with that said, our asymptote. So our asymptote is at y is equal to negative 4. So at y is equal to negative 4, so at 0, 1, 2, 3, negative 4, we have our asymptote. So it just tends towards that line, but it will never, ever, ever touch it. Now, let's go ahead and find our y and x intercept. So y-intercept is the easy one. The x-intercept is what how we use our logarithm. So for our y-intercept, remember our y-intercept happens when we let x equal to 0. When we let x equal to 0, all we're doing is a straightforward substitution into our function. So our function f of x, we're finding f of 0. This is equal to 2 times 10 to the power 0 minus 4. Easy to solve for this. 10 to the power 0 is 1. 2 times 1 is just 2. So 2 minus 4 will give us -2. And you can visually see that there. There is our -2, so our y-intercept. For our x-intercept, conversely, we just let y equal 0. And we are going to, or specifically f of x, should be specific f of x be equal to 0. And we'll go ahead and put that in, let that equal to 0, and then we're just going to solve for x. So a few inverse operations we need to apply. The first one is we're going to add 4 to both sides to get rid of that -4. And then we have a 2 times this term here, so we're just going to divide both sides by 2. And now this is the most basic format that I can get this exponential equation into. So I'm going to write it in the format of a log. So log base 10. So base is 10. What we'll find the log of, which is 2, is going to be equal to x. So when we put this, move this aside here, we put this into our calculator, log base 10, calculate up a little bit, there we go, log base 10 of 2, execute that. And so our x-intercept is at approximately 0.3010. So x is approximately 0.3010, which is that point over here. So using our logarithm, or using our logarithms rather, we now have a tactic that is different to the solve function in order to get our x-intercepts. Alright guys, that is it for 13F. You're going to use this double to approach the questions for 1, 2, and 4 every second one, A, C, and E. Best of luck with this exercise, guys. I'll see you guys next week on Monday.